I would like to begin by thanking the organizers of this conference. I'm very glad to participate remotely from Spain. My name is Dr. Cristina Cabello, and I will give a presentation on how to evaluate dust accumulation on sheltered archaeological sites based on colorimetry. This research has been undertaken by two Spanish universities, Universidad Autónoma and Universidad Complutense, both from Madrid. This is an interdisciplinary research with strong practical application. Archaeological excavations imply exposing the historic and artistic remains from past cultures to a new environment, different to the one they had while buried during such amount of time. The great majority of these remains correspond to architectonic structures, but also delicate decorative programs. Mural paintings and mosaics are among the most vulnerable type of immovable heritage that can be found exposed in situ. The action of water in the porous materials and in the layered structures is the most frequently mentioned decay factor, in form of freezing or salt crystallization pressures. But thermal variation and biological factors can also lead to disgregation, exfoliation, and fracturing. Shelters have been extensively considered preventive conservation measures for archaeological sites after unearthing, because they act as a barrier against sun and rain and thus prevent further damage. They can even modify the microenvironmental conditions inside to produce a more favorable environment for the preservation of the site regarding humidity, temperature, and air quality. In addition, the preservation of a site can have positive effects in the local community if considered a touristic attraction, for instance. A long-term debate in the conservation field is the effect of sheltering the remains. In the literature, it's possible to find numerous cases of shelters that are not protecting the site or that are introducing decay factors not present before. A significant case is the Villa del Casale in Sicily, Italy, where an enclosed and transparent shelter induced salt crystallization and the subsequent deterioration of the mosaics. From another point of view, shelters may affect the visitor's experience. The disruption in the archaeological landscape is a very negative aspect, because shelters may change the relation of the site with its context. It's important to mention that archaeological remains are not only appreciated for its historic and documentary values and as a source of knowledge and archaeological research. They also contain the aesthetic and artistic attributes primarily associated with the decorative elements, which are also part of the archaeological complex. Therefore, the protective role of shelters needs to be guaranteed so the other negative aspects of its construction are justified. In this sense, a continuous monitoring program to assess their effectiveness is vital. The Service for Conservation, Restoration and Scientific Studies of Archaeological Heritage at Universidad Autónoma de Madrid and the Applied Optics Group from Universidad Complutense de Madrid have carried out two studies of one of the most important archaeological sites in Spain, Complutum. The site is located in the modern city of Alcalá de Henares, in the middle of the Iberian Peninsula. Complutum is a Roman city built by Emperor Augustus in the 1st century AD. The site has the highest protection category of the Spanish legislation since 1992, which is the result of its relevant significance, but imposes limitations in terms of restoration interventions. There are two areas of the site that were covered. The shelter at the house of Hippolytus, constructed in 1999, can be described as a partially enclosed design, which allows some air exchange through the lateral cladding. The shelter at the house of the Griffins, of approximately the same covering area, was built in 2011, with a dome-shaped steel structure classified as a partially open shelter. The reason behind covering was to protect the ornamental elements from weathering. There is an exceptional decorative program based on mosaics at the house of Hippolytus and mural paintings at the house of the Griffins. However, we like to focus on the mosaic at the house of Hippolytus, specifically the central one from the 3rd century AD. It has a high artistic value. The main scene follows a North African tradition representing three cupids fishing on a boat surrounded by Mediterranean fauna. It also holds important documentary information as the name of Hippolytus, presumably the master of the villa, appears on one of the sides of the central motif. As we said before, an environmental monitoring program is really important to understand the effects of shelters on the remains. In the case of Complutum, our recent monitoring has shown that both shelters protect the archaeological remains from the outer damaging risk, such as the summer extreme temperatures and diurnal temperature variations. Nevertheless, it was found an excessive dust accumulation on the horizontal surfaces inside the shelters, especially visible on the mosaics. Particulate matter is deposited during the dry phase, enhanced by the absence of rain and the changes in wind behavior inside the cover. The accumulation of coarse particles is likely to alter the appearance of remains and make visitors have a negative impression of the place, associating it with neglect. In addition, the chemical interaction of the most reactive particles with the historic surfaces usually leads to soiling, and as a consequence, physical decay and darkening or discoloring, mainly highly polluted areas. The great majority of studies related to the quantification and effects of particulate matter deposition in indoor environments has concentrated on museums, libraries, and historic houses. However, archaeological remains are especially susceptible to the effects of dust accumulation and soiling, in contrast to artifacts in museums, which counts with controlled environments with filtration systems. Complutum is taken care of regularly, and the maintenance program includes periodic dry cleaning and exceptionally wet cleaning of the surfaces. Nevertheless, the cleaning method is utterly important for the future preservation of the remains, as water is one of the most relevant decay factors for inorganic porous materials. The effects of too frequent cleanings can be underestimated, and this could be taking place by periodic routine unnecessarily. Therefore, visual changes after any type of cleaning should be objectively evaluated, so a decision can be taken regarding appearance and decay risks. For that reason, this study proposes two methodologies related to the accumulation of dust on sheltered archaeological remains. The amount of particulate matter deposited inside the shelters at Complutum and its variability with time were evaluated by studying the percentage of light transmitted through transparent and sticky film samples exposed passively at different areas within the site. This allowed estimating the areas of major affection within the site so decisions about its regular care can be objectively taken. The other project looked into the consequences of sheltering for the contemplation of mosaics, horizontal archaeological surfaces with high aesthetic impact. For that reason, reflectance, color, and line changes due to the presence of deposits on the central mosaic at the house of Hippolytus were studied, and the overall reflectance of the mosaic after a dry and wet cleaning was evaluated. In the first case, dust collectors were made of transparent PVC film with UV protection, coated with a polyacrylate adhesive. 12 of them were exposed horizontally for 1 month, from June to July 2018, and another 12 for 3 months, from April to July in the same year. The collectors were distributed in sets of 3, inside and outside each shelter. Each set was placed at different positions, so it was possible to obtain a wider representation of the site without affecting the contemplation of visitors and reducing the possibility of sample loss due to manipulation. This is a passive sampling system that makes it highly suitable for low-budget sites. In previous cases, the quantification of the particles was undertaken using microscope of high magnification, visually or by automated image analysis prior converting the pictures to binary format. Instead, the use of light transmittance in this study significantly reduces the processing time and has into consideration all particles, not only the dark ones. After exposure, the changes in the light transmittance were spectrally characterized in laboratory conditions by lighting the samples with a collimated light source, and then by measuring the total spectral transmittance and transmitted spectral energy by means of a spectrometer connected with a short optical fiber cable to the integrating sphere. The percentage of transmitted light was calculated taking into account the normalized spectral energy distribution of a blank sample used as a reference and each collector after exposure. The amount of transmitted light was used to obtain an objective value from the spectral point of view of the quantity of the light perceived by visitors. Lower light transmittance values relate to greater dust accumulation. The central part under the shelter was less affected than the periphery. There, the dust collectors showed a decrease in light transmittance of approximately 7% at the house of Hippolytus and 10% at the house of the Griffins. If both shelters are compared, the periphery of the house of the Griffins was more affected than in the other shelter. However, the dust coverage was greater outside, specifically after 3 months. This can be related to a low precipitation rate during the monitoring time. But at the end of the experiment, the accumulation inside the shelter was also significant. This presumes that the observation of the remains will be very much compromised in a relatively short period of time. The other study made use of a Lumican camera for determining overall lightness, chroma, and hue angle when the deposits lay on the mosaic. The measurements were taken after 6 weeks of exposure from April to May 2019 and compared with values from the same surface once cleaned, first by dry means and then by wetting cleaning. For calibration purposes, it was used a wide reference target with a 75% reflectance and a color checker panel, both placed in the same plane of the mosaic. In addition, a conical Minolta spectrophotometer was used to measure the reflectance of specific areas of the mosaic. For this purpose, measurements were taken in red, black, and white tesserae at the most prominent part of the mosaic, which is especially rich for its decorative components, and only taking into account the visible range from 360 to 740 nanometers. After 6 weeks, there were noticeable visual changes. The deposit made the colors less sharp and the volumes of the figures less defined. Providing that a reduction in reflectance of 10% is estimated to be a consistent threshold for cleaning, the deposition on the black tesserae can be considered inadequate. In addition, these were prone to a higher visual disruption, as in this case, the dust tended to be light in color. After cleaning, all the tesserae became closer to their respective color and spectral characteristics. The reflectance highly increased in the white areas, which were perceived as lighter. The main difference was obtained after the wet cleaning, so this could be the most suitable cleaning process for obtaining significant results, in spite of the risk that water implies for the conservation of the mosaic. The quantification of dust accumulation by light transmittance implies a new method for determining indoor dust coverage, which allows comparing different areas of the site and different sites. Another advantage of the system is the processing time and that it can also help establishing the frequency of cleaning if repeated over time. However, the different angles of observation and the specific light source at the site need to be taken into account if the intention is to understand the effects of dust for visitors. Additionally, reflectance, lightness, and color changes measured by a spectrophotometer have proven to be very effective in order to assess how the color of the decorative surfaces is affected by dust and to determine the best cleaning system. Spectral and colorimetric characterizations have been used extensively in the field of cultural heritage, even for support restoration, but the application to this specific area is still underused. The research undertaken at Complutum provides valuable information about deterioration factors affecting the site. Furthermore, this methodology permits determining the effect of different types of shelters on dust accumulation, which is a clear contribution for the shelter design criteria. In addition, this project has proposed a straightforward methodology to evaluate the risk of soiling on shelters remains without using invasive and destructive technologies. It can support site management decisions and be applied to other archaeological sites. The use of some low-cost methods means that a wider range of sites can be benefited. This is the end of the presentation. Thanks to the audience for their attention and thanks again to the organizers.